Hi, welcome to the video on square and cube roots. Our standard is 8EE2, write and evaluate square roots and cube roots. So we need to change our I can statement into an essential question. So you are writing down, how can I find square and cube roots and solve equations involving them with the question mark, please. Once you have that written down, pause it and then continue. All right, we're talking about inverse operations right now. So addition and subtraction are opposites or inverse operations. Multiplication and division are as well. In this lesson, we're looking at the opposite of squared numbers, which is the square root. So you're going to see both of them today. Another vocabulary word that we're going to talk about is the radical sign or the fancy math term for the square root of something. So those are our vocabulary words that we're going to be talking about today. All right, if you could take a moment and pause the video and then list all the perfect squares between 1 and 300, kind of like a personal challenge. And then play it again and we'll review them. Did you get them all? 1 squared, all the way up to 17 squared. Most of us know up to 12 squared being 144. But if we could memorize the 13 squared, the 14 squared, the 15, the 16, and the 17, I'm sure I'm hiding it there. There we go. There's the rest of them. If we can get some of the higher ones memorized, it's going to save us some time in the long run. All right. So, as we're talking about positives and negatives in this unit, we need to remember that every positive number has both a positive and a negative square root. So we're going to be looking at negative numbers inside and outside the radical sign today. So this is something we need to get down. The square root of 25, we're looking for the positive square root of 25, which is 5. If we put a negative, this negative outside the radical sign, the negative square root of 25, we're talking about an answer that is negative 5. And then this is something new to us, seeing a positive and a negative outside the radical number, which is kind of fancy for a 6th grader. A positive and negative number is looking for both square roots of 25, which could be 5 or negative 5. So that's kind of a shortcut that we use. All right. As we look at our practice today, we need to remember we have our base and our exponent, and we're trying to undo what we did in the previous lesson. So the other day we talked about 4 squared being 16. Here, we're trying to undo the inverse operation of what squared is 16. So, as I just talked about, 4 would be the base, 2 would be our exponent to get to 16, so that does work in this situation. So there's a negative here on the outside of the radical sign, so we're going to go ahead and put negative 4 for our answer. Number 2, we should know the square root of 49, so we're going on those perfect squares again. So 6 squared is 36, 7 squared is 49, so our answer is going to be positive 7. No sign in front of the radical sign, so we're good to go for number 2. Number 3, we're looking at this positive and negative. We're going to ignore that for the first second. Look at the square root of 81. We know that 9 squared is 81, so to undo that, we put a 9 down. We're going to drop this positive negative sign, meaning that positive 9 squared is 81. And negative 9 times a negative 9 is also 81. So we're going to have 2 possible choices for number 3. In number 4, we're looking at the radical sign being in the inside. And we talk about this a lot in your next class, but there is no real solution for a negative to be inside that radical sign. That's a new number system that you talk about in your next class, so we're writing no real solution. You can also just write I for imaginary if you'd like on your test. I'm sure that some of you short-handed people love to abbreviate that one. So that's just an I. It's imaginary. It doesn't exist. The other part of this lesson has us undoing equations. And this one is really simple when we're talking about the inverse operation of square and square roots. So to undo an x squared, we're going to take, there we go, the square root of x. If you remember your equation unit from last year, whatever you do to the left side, you got to do the right side. So step 1 is taking the inverse of the squared, or the square root of x and 49. Square root of x is x. The square root of 49 is going to be what? 7, right? Not so fast. We need to make sure that we have positive 7 and negative 7 as our answers. So 2 choices. We cannot forget that symbol when we're talking about equations. In this second example, the variable is on the right. That should not matter. We're undoing the equation in the same manner, taking the square root of c squared and the square root of the numerator and the denominator on the left side. So the square root of c squared is going to be c. Square root of 16 is going to be 4. Square root of 49 is going to be 7. And we have to make sure that the plus and the minus are in front of our answer. Okay? Cube roots. A cube root of a number is one of the 3 equal factors. So instead of having the base multiplied 2 times, we're going to have the base multiplied 3 times. So make sure you have that down. And if you notice, it says just to what the heck just happened? List all the cube roots between 1 and 100, because I'm not going to make you go so high since we're using a base and an exponent that's to the 3rd power. Pause it, play it, let's see if you're right. 1 cubed is 1, 2 cubed is what? Survey says 8, 3 cubed is 27, and so on. Shouldn't have taken you that long. Moving on, let's fill in our notes. The cube root of a positive number is a positive number, and the cube root of a negative number is a negative number. And this should be easily filled out with our exponent discussion earlier in the unit about odds and evens. Got it? Moving on. All right, we need to put down some examples. So let's take the cube root of 729. Let's think about that for a moment. Can we estimate, see if we can get a number that goes as high as 729? All right, let's think 8 times 8 is 64 times 8. Estimate that's not high enough. 10 times 10 times 10 is too high at 1,000, so we got to go between 8 and 9. So you're right, or 8 and 10, it is 9. Okay, let's take a negative example. 3 to the square root of cube root of negative 64. So we know 3 times 3 is 9, times 3 is 27. So we try the next integer, which is 4. And 4 times 4 times 4 is 64. So that works out for us. But we have the negative within the radical sign. So we try the negative 4 times negative 4 times negative 4, and it does work out for us. So cube root of negative 64 is going to be 4. We already talked about the cube root of 1,000 being 10. Are we good? Do we have these 3 examples written down? Let's solve an equation. If we see s cubed is equal to 8, how do we undo this equation? Make sure you got it written down. Solve it just like we did with square roots, taking the cubed root of s cubed and the cubed root to the 8. Make sure your symbol's there. This gives us s cube root of 8. We're thinking 1 times 1 times 1 is 1, so we'll try 2 times 2 times 2, which is 4 times 2 is 8, so s is equal to 8. Do I need a positive or a negative sign? Nope, it's positive. I checked my work. I'm good to go. Okay, I better see these 4 examples written down on your notes when you come into class tomorrow. See you later. Bye-bye.